And if you recall, in our discussion with arrays, we pointed out that arrays are ordered, arrays are type safe, but arrays are not unique. We could have the same value repeat over and over again. Sets are different in this matter. Sets basically are by nature unordered, but they are also a collection of similar types. So they are type safe. So you can have a set of strings, you can have a set of integers, you can have a set of your own custom defined objects if you want, but they have to be of the same type. They are type safe. Now, sets have to be unique though. Since there is no ordering, no indexes that are being maintained, a set can have only one way to refer to a value, so there has to be some level of uniqueness. And we are now going to explore sets with a working example. And as you see, I have got a sample set which is defined here. And I'm going to start by saying it has four different types of musics which are present. There's rock, jazz, classical, and hip hop. All good and dandy. I click on my results pane, expand it. I see the four values. Everything looks good. But you may come back to me and ask me is then what's the difference between an array and a set? That's exactly how you defined and initialized an array. And you're right. If I start looking into the type of my set, it is actually an array. It is not a set yet. And the reasoning behind this one is that just as we see with fractions, by default they're doubles instead of floating point numbers, we see the same thing with single letter double quoted values. By default, they're strings, not characters. You have to explicitly tell Swift that you intend to use one type over the other. By default, if Swift sees a lesson, a starting bracket and a closing bracket and bunch of types defined, then it's going to assume that they are an array. There's a collection of type array. It's not going to assume that it is a set of type array, and primarily because arrays are more used collection. Now, if you really wanted it to be of type set, you need to use type annotation, and you need to explicitly state that it is of type set. Now I did so, and you can see clearly that it is now a set of type strings. The other thing which we talked about was unordered. And the question which you can come up here is that, okay, are they truly unordered? Simplest gesture is to actually run the piece of code and check for yourself. And what I'm doing is that I'm now just going to have my set printed to see whether the order matches or not. And I didn't even have to do line number 6. It was there in line number 1 as well, but we'll visit that in a minute. If I say show result, if you look at it, I added the elements into the set as rock, jazz, classical, and hip hop. But when I look in here, it's actually returning me back jazz, hip hop, classical, and rock. So the order is actually different than the order in which I added the elements. And you can actually go and keep requesting the same set over and over again. You can or you should expect that the order can change at any point in time. You should not rely on the same order being returned back to you in a set. If you need order, you have to use the array data type and not the set type. So that takes care of our ordering functionality as well. So the sets are unordered. We told that their sets are type safe. So let's check on it in a bit. Let's say I'm defining a set here again. Same thing, but I want to add to it now 5. Maybe 5 is a new musical type which is present. And suddenly I get an error saying that, okay, I cannot convert into the expected type string because using type inference and set, which is type annotation, the combination of two is telling Swift that this is supposed to be a set of type string. So you can't really mix and match types even inside the set. They have to be of the same type. Now I named both type inference and type annotation here because as part of the annotation exercise, I just told that it is of type set. but I never told that it is of type set string. The string portion is being figured by Swift by looking at the types which are present inside inside the set. Now, if I remove the 5, I go back in and you see the type is set string. Set, I am doing the type annotation for, not the string that's being inferred. Now, could I have gone forward and defined a set string as the type? Of course I could have. So I could have gone back, and this time I'm going to go with a variable. Okay, and new set, and I'm going to say that this set is going to be a set of type string, and that's it. I have defined new set as a set of type string, and now if I really want to set a value for this, I can go forward and assign it values as I go. So I can go and do this, and new set has now 2 values. Same functions like we talked about in arrays. There are functions which are available, which will let us know the size of the set, and they will also let us access or insert new values for sets which are of type variable, but they are not constants. Constants again, same thing as arrays. It's a constant. You really can't go forward and change it. You can't remove values out of it. You cannot add values out of it. It's a constant. So let you will not be able to do that, but we're gonna start with an example, which is our new set right now. So let's go with new set Rocket Jazz. Let's see if I can see the count which is present here. Now, one thing which is true here, you probably saw as I was pressing the dot and the options were coming up. There's an option for the word capacity, which is present here. And capacity is 3. Now, since it's a variable, it can expand. Swift is going to internally assign it a default capacity in the beginning. So default capacity which Swift assigned to the set was of 3, and the same is true for arrays as well. It's just that uh, originally it assigned it a size of 3 because originally there were 2 values, and it kept 1 as a buffer or as something that is kept at handy for the original capacity. But it does not means that it cannot go beyond 3. So let's try it once. Okay, so let's say I go to new set and I go forward and say insert, and I want to insert classical. Okay, so I went forward, I said okay, I want to insert classical. Now, okay, it's inserted. Now let's go forward and insert one more element, and this time I'm gonna insert hip hop. Okay, done. That's inserted as well. Now, if I look at the count of members which are present in new set, I should have a count of 4 elements. If I look at the capacity of new set, it is going to be 6 elements. Now, it wasn't a necessity that it was going to be 6. It's internally Swift could have assigned, but looks like Swift in this example assigned in chunks of 3, not a necessity again, right? Do not count on these things to work exactly in that fashion of blocks of 3. It can change between Swift versions, it can change on your initialization, set size. But the point is that Swift is internally allocating some capacity for optimization or optimizing the performance. And it's expecting that you, because it's a type variable, you to add some, but probably it's not expecting you to add too many. But if you cross the limit, it actually goes forwards and allocates more for you. Now, one thing which we can also do is that after I added classical, I can go forward and just print the count and capacity one more time. And you see, at that point in time, the count and capacity actually matched. So just didn't go and define and went forward and assigned you more. The reasoning is that assigning more capacity is cumbersome. It's actually is going to require some more cycles in the memory, in CPU. So it's not going to do that unless you really need it. It's actually originally assigning you some more capacity to save on those items. But if you really need to cross it, only then it's actually going to go forward and do the work and reassign capacity for you. Now that thing is behind us. Let's move on. We know that, okay, the sets are type safe. They actually have, they are unordered. We have seen those values already. So we know that they are unordered. And another check which we can do is that we added classical. So let's say new set and print the new set. Okay, so I'm printing in the new set in a couple more places. As you say, we start with rock and jazz, and now it's classic rock and jazz. If I look here, it is now classic jazz, hip hop, and rock. So it's just random order. So we are not going to worry about ordering. Next piece which we want to touch with the sets is that the sets are, let's just type it up. We're going to keep probably these values as it is. Sets, as I was inserting a value, I went forward and inserted hip hop. What got returned back was a tuple. If you look at here, as a return back, I'm getting two members back. I'm not getting one member back here. And if I do a show result, I'm getting two arguments back. One is inserted is true or false. Second is member after insert is hip hop, which is the name of the value of the member that has been inserted. So nothing out of the ordinary there. But the main point is that it's returning me a tuple back. And the value is returning me back inserted is true and false. The question arises is when it can be false. That's where the third point comes into the picture, which is that sets are unique. And what it means is that you really can't go forward and keep inserting the same value again and again, because for sets, there's no ordering of any list that is maintained. It's always going to try and refer to its elements by value. And so the values have to be unique. So what happens if I try and insert the same value again? And for example of string, I can go forward and say, I want to insert rock again. Now, when I try and do this, let's inspect what I get back in tuple. So it tells me that, okay, it failed to insert this new value. And the reason it failed to insert this value was because it already existed in the set. So you really can't go forward and have two rocks inside the same set. It will not know which one you're referring to. So it's not inserting it. That's the uniqueness part of the sets, which we actually talked about earlier on. Now, this is also true in case all my examples were strings, but I could have used int set. And again, I will have to define that it's of type set. Okay, I can say that it is of type set of int if I wanted to. And then I can go forward and initialize it with certain values. Okay, so it's there. Okay, so it has some values inside it. And I can go forward and then say is for the insert, let's go forward and insert 4 again. Right? As expected, it's false. It can't insert the same value again. It's going to error out. But yes, I can go forward and insert a new value. Let's say I'm going to insert a 9. And I'm intentionally numbering them all in a sequential order. We'll see about it. Okay, so I went forward and just printed the insert again. As you see, I had 2, 3, 4, 6, 7, and then inserted 9, but the ordering I get back is anything they are unordered by nature. And that's pretty much all that you will have to know about sets. Main thing you need to keep in mind is that sets are always going to be unique. You can't have duplicate values in them. They're going to be unordered and they're going to be type safe. Next, we are going to talk about dictionaries.